can pick that up and actually use it as part of the flow process or BAU process. So we started out developing the solution as a tactical solution in the DSL, mainly to give corporations teams something to use. And our long-term goal was really to actually move that solution into a proper environment in the data lake, which was being built during the time that we actually started building the solution for corporations in the experimental lab. So the data lake at ASIC took about a year to build, and in the data lake we've got a proper pipeline that can store and analyze unstructured data, so text data, and also we can actually use more sophistication in terms of data extraction tools. So we've actually used AWS TextRack, which is probably a bit better than other Python packages that we've got, particularly when we've got tabular data, and also low quality scanned documents as well. So in the second diagram there, we've actually started at the beginning of this year migrating our current solution to the lake, which will automate the process end to end, and it will be fully supported by our data operations team as well. So that's really the approach we've taken, and Alistair now will run you through the solution. So over to you, Alistair.
Thank you, Quan. So yeah, I'll talk a bit more about the sort of technical details and our learnings from this project. So you see here on this slide, this is the output of our application, of our work. So yeah, this is basically it. So you can see here we're reading in PDFs, and then we're literally just pulling out these fields. So you can see here, I've got the ACN, the exchange, the purpose of the prospectus, and so forth. So the majority of these fields are pulled out via regular expressions. So we were literally just coding in a lot of rules. But I know Juan said we weren't doing a lot of AI here. There's a tiny bit of ML. So if you look at the sector, for instance, we're using the NLTK corpus to pull out the relevant sector. You see here, the top one, it's pulled out the mining sector from that prospectus. Just something to note. So these three prospectuses are what we would consider somewhat riskier, and you can see the reason why actually is because these are actually resource related prospectuses. So and this was sort of information given to us from the corporations team. So whenever there is a resource related prospectus, that is a flag, and that is something that they'll look further into. They'll sort of have a human give it a bit of a closer read. So that's it doesn't look like much, but it does save quite a bit of time on their end on the initial screening, and we are working on additional features. So one thing I'm doing right now is building in rules and building in a model that can look at this if a prospectus, if a company is trying to raise funds to pay back existing shareholders. So that is an additional risk. So if a company or an institution is trying to raise money to pay back existing owners, that's potentially something that is risky, and so that is something that we will need an analyst to look at. So that's that slide, and I'll talk a bit more about the benefits and our learnings now. If you can move to slide 6, thank you. So I guess as Pun alluded to, this is the first application that we're using in our internal data lake, and so there was a bit of a need to sort of show results, to show some quantitative results, and that's a bit part of the reason why we picked somewhat relative low-hanging fruit here, but that does give clear results. So previously every prospectus raised would need a human eye, need at least 30 minutes to look time to look at it, and if the analyst decided it was slightly riskier, then it could take up to 4 hours, because analysts would pass the results on to managers and senior managers, and they could potentially even contact the issuer. So now we've saved that time. So now it goes down to 5 minutes for every prospectus. Analysts can receive the entire table. Senior managers can receive the entire table, scan it very quickly, and just pick out the riskier ones and have a read of those ones. We've also got the results saved in a very secure and very performant way. So we're building a data lake. Things aren't stored in separate Excel sheets from each analyst in SharePoint. It's on it. We've got a single source of truth that has every single prospectus rated since, you know, from the last 12 months when we began. And so because of that, we can have analysis over time. We can see how we have potential to do other forms of analysis. We can see, you know, how many prospectuses are related to mining over time. We can see prospectuses are getting more risky or less risky. We can see if it correlates to, you know, certain economic announcements and things like this. So there's potential to do much more analysis based on the types of prospectuses now that we have this single source of truth, now that the data can be pulled out very quickly. The final slide I'll touch on now is on the learnings. Yep. So even though this was the first application we created with the data lake, and so you can imagine there are a lot of learnings here. For us in the data office, it was mostly related to the tools, and it seems like fairly small, fairly sort of minor issues. But even the types of packages we found to be quite tricky, and we found the sort of need to do our research. So previously we were using open source packages like PyPDF. When we used commercial ones like Amazon Textract, it's the quality was much better, but the way we processed it took a lot of time to sort of write code to actually read tables properly, read scanned documents properly. So we discovered we needed to build that sort of thing in. It was easy to sort of hand wave and think that packages are the same and we could just plug and play, but there is a learning cost there in terms of figuring out new things. Even though the things are more efficient, there is still that initial fixed cost in terms of learning the new technology. And in terms of the data, so with this particular application, one of the reasons why we couldn't use a model is because that sample size is too small. So we had students annotate the prospectuses for us, but even then, when we went back 5 years, that really is not enough to train a model. Prospectuses vary quite considerably. Every company, every institution will write a prospectus and present data in a different way, because ultimately it's a marketing document for investors, for potential investors. And so every company will word things in a way that reflects well on themselves, and hide things that don't. So it's hard to sort of fit a model and get accurate results. And one of the needs from this project was to show proper rigorous results and show clear efficiencies. We didn't want to give like a proof of concept. We wanted to build an actual product that will save time. So we leaned on clear rules, and we're starting small with clear fields that are accurate, that are high, that we can build with a high degree of accuracy. And the hope is that we can work from there as more prospectuses come in, as the technology gets built, as we have a bigger source of truth. We can hopefully fit some models and build sort of process and sort of analyze things that aren't really analyzed right now. And the last issue was on that workflow process. So we're still sort of figuring this out. So I mean, we talked to the business team, the corporations team, and we got our initial sort of requirements. But the idea of going back to them, seeing what works, what doesn't, feeding that back into the model, having that sort of human in the loop, so to speak, we're still sort of feeling away on how best to do this. That sort of thing takes a lot more time than we expected. It's easy to sort of go away and build what we think is good, but then coming back to the business, working with them, seeing what they actually need and what actually saves them time, for us at least, was a bit of a learning curve. And that's all I have. Anything else you'd like to add on this?
No, Anastasia, you are right on time. So let's move to Bill. Thank you very much.
Thank you.
Okay, I guess this is our turn. Yeah, thank you. So my name is David Zhang. I am an Ethics Senior Director leading the NLP capability in the ATO. Next page, please. Next one, please. So for today's presentation, I will present an overview of our NLP capability within the ATO. My colleague Francois is going to talk about our cloud journey. And Inama is going to talk about the NLP for international risk identification. And Hong will talk about automated review of documents. Next one, please. ATO actually has applied NLP in a pretty wide range of application already. So, but in terms of business process, we are mainly focused on these three areas like operational improvement, risk and identification management, and data enrichment and augmentation. So what do we do next? Cloud migration obviously is the biggest thing in our world. And we also want to build a generic pipeline to allow fast application development. The reason for that is because so far we have built a lot of bespoke pipeline. Every single solution we build one pipeline. So that is not something that we want to do in the future. We want to have a generic pipeline that whatever new application that we have, we are able to deploy using the same pipeline. And we will also want to expand the NLP capability to support wider compliance activities. In the past 10 years, there are major breakthroughs in computer vision technology. We believe that the current 10 years will be the NLP world. So for the ATO, we are moving from just NLP applications to computer vision and NLP power AI applications, such as like the virtual assistants for assisting text return preparation. Next one, please. So when we're talking about AI, NLP is really the foundation of automation and artificial intelligence. One of the AI priority in the ATO is to use NLP to improve our client and staff experience. For the AI strategies, here are some of our goals. We want to make our data accessible for all AI applications. We also want to put trusted data and insights to the hands of our users. We also want to create more values from the data. Also, we want to unlock all the data potential in unstructured data. So we know that there's a lot of intelligence, lots of information, lots of values in unstructured data in documents. So here are the three focus that matter most to our business. So we will play a key role in the whole of government data sharing. Given that we have large volume of data, we will improve our risk profiling and analysis. And we want to develop and create a strong data analytics culture. Next one, please. So these are the common tasks in our ATO. For the OCR, we convert our images to machine readable text. At the moment, we only focus on the print and text, type text. So we are not focusing on any of the handwritten OCR yet. For the document parsing and layout extraction is also a really important foundation type of technology to enable NLP tasks. We convert document contents into JSON format to give structure to the text. And we also index and search for large volume of data, like all the civil cases. We index those data, allow us, our case officers, to search them. And we also do a lot of semantic context extractions. This is a key technology for document understanding. So we extract key risk, key themes, and also like metadata from documents. Red scraping is an important tool for us to enrich our data holdings. And also, of course, data document classification, content categorization. So for whatever fancy task or application that we are doing here, they can all break it down into all these small components. Of course, we also do name entity recognition, and we also so identify all the key interests. And then we identify their relationships, such as like we identify trustees and beneficiaries in a trustee. Then we bring back the data back to the ATO to match with our client register list to see who they are. So in the ATO context. Next one, please. We already use a wide range of NLP algorithms, such as all these deep learning algorithms listed below. My colleague Inanna and Hong will talk about some of these algorithms in their talk. And we also use large number of open source pre-trained models, so that with all this availability of these pre-trained models, we shift from the research focus to high quality production ready application development. The language that we used are Java, Scala, and Python. One of the reasons that we actually use a lot of Java and Scala is because our system is Hadoop. So Hadoop is allow all this native Spark code. So that's why Java, Scala are still our main language. But we also use our team machine allow Python development and deployment. We also have two out-box tools. We have IBM Watson, which is an off-the-shelf IBM product to collect and analyze unstructured data. And also Linux is another commercial tool that we are able to index and search larger amount of documents. It actually can pass a lot of different formats of documents. Next one, please. For all the pipeline that we're working on when we build, they all have all these four components. We have like data sources. EDH is our data storage. And then we deploy our analytics model into EDH, but we also have our analytics platform for allow our deployment. And we also use Shiny or other web framework to build user interface to allow users to look at the insights, get the decision and actionable intel. This gives us a good segue to my colleague Francois to talk about our pipeline that's in the cloud. Yeah, thank you.
Thank you, Debbie, and good morning, everyone. My name is François Petitjean, and I'm a data scientist at the ATO. And today I'm going to talk about a proof of concept that we've developed at the ATO, which is about ingesting documents on cloud. If we can go to the next slide, please. So first, I'm going to talk a bit about why the ATO is investigating cloud for data analytics. So the first thing is something you probably know about, which is that cloud offers the possibility to have on-demand infrastructure. So at the moment, the ATO is basically catering for the worst case scenarios. We have as many servers as we need to cater for tax time, basically, or the peak infrastructure for the peak demand. So the advantage of the cloud is, of course, that you basically pay for the servers when you need them, and if you don't need them, then you don't pay for them. So that's what we call scaling out and in. So scaling out means having more machines deployed when the load on the infrastructure is bigger, and scaling in is the opposite. And I want to draw attention to kind of an extreme version as well of this scaling in and out, which is the use of microservices. So the idea of microservices, such as, for example, AWS Lambda or Azure Functions, is that you only pay for every time the code is executed. So you don't even have to rent out a server. You have a piece of code that is executed by Azure, AWS, or Google Cloud by their servers, and they're the ones who manage how many servers should be on and off. And if nobody calls ever your code, you don't pay for it. So this is kind of an extreme level of granularity. Also for the ATO, another advantage of cloud is to have up-to-date hardware. So we know that for machine learning model, and especially large neural networks, GPUs, so graphical processing units, can be really useful in training our model quickly. And so, but it's really difficult to keep up to date with the latest hardware. So when you might have bought, for example, maybe 6 or 7 years ago, 10 1080 NVIDIA, then went to a K80 and then V100. Then at the moment it's A100. It's really hard to keep up with this infrastructure. And this infrastructure does bring a lot of advantages in mostly training time of the models. So that's for cloud in general. Now I'm going to talk a bit about the documents analytics pipeline that we've been building on cloud. No, not quite. Sorry, can we go back to the previous slide? Thank you. So the idea here is that what we want is to have a proof of architecture for handling scans of documents. So because we manage a lot of documents at the ATO, and so the idea is to have a pipeline where we will ingest these scans of documents, and I'll explain what the pipeline is doing a bit later. But that was a good test for clouds for us. They're a good test bed because they're high GPU loads. So training this big, we have an image and a text classifier, takes a lot of resources. And so we wanted to push a bit what we could do with GPUs there. Another here again is about the scaling in and out. So document ingestion can be quite bursty. You can imagine that we have data dumps, so it might be the Panama Papers, or it might be that corporation is sending us a lot of documents one at a time. So it's really good to have this pipeline on cloud for this reason. And we wanted to test different cloud providers. So we've been testing AWS and Azure. We wanted to be a bit complete about the library. So we've basically we'll see there's an image classifier that's trained in TensorFlow and a text classifier trained in PyTorch. And once all the documents have been ingested, we store them in a text database, which is Elasticsearch. If you can go to the next slide now, please. Thank you. So this is basically the way the pipeline works. So at the top left, we have someone uploading documents. It might be a corporation, it might be a taxpayer, it might be a journalist with a data dump. So we have this document. And the first thing that we have, the module number one, is an image classifier. So this image classifier is basically deciding if this is a document or not. And the reason is that if it's not a document, we're just going to store it. We're not going to send it to OCR and pay for the cost of OCR, etc., etc. Once we've decided that this is a document, then it's sent to OCR. And this is where it's also really interesting for us to study cloud, because cloud is not only about infrastructure, but it's also now providing software. And as ASIC's been talking about just before, they've been looking at AWS Textract. So it's the same idea here. So OCR software are actually really, really good and better than the open source version that we have been having on-prem. Once the document's been OCR'd, so we have now a text version, so a machine processable version of the document. And then we do two things. First, we will store this document in a text database. So that's module 4 at the bottom. And here, I call it text database, but it's Elasticsearch. So it's more like an indexing database that you can search. And the other thing that we do is we will enrich what we know about these documents by running a text classifier. So the text classifier might be, for example, deciding what type of document this is, so that then we can search by this type of document. So this idea is that this is a generic pipeline that we can use at the ATO to ingest documents, and then we can configure it to do a bit different things, like the image classifier might be filtering different things out or in, and the same for the text classifier might be enriching with different components. And at the end of the pipeline, we have a tax officer who has access to the text database and can basically query. So you might imagine that you're looking maybe for a taxpayer that was presented in the Panama Papers, and you're looking for their name in the whole database. If we can go to the next slide, please. I just wanted to quickly give you two take-home messages from this proof of concept, proof of architecture that we had for managing documents on the cloud. So the first one is on the left. So on the left, what I'm presenting here is the time it took to train the image classification model. So the filter that we have at the top. And so the top graph is the time that it was taking, and the bottom graph is how much money it was costing to train the model. And on the x-axis horizontally, you can see that you're getting a bigger and bigger machine. So from a small CPU machine with 16 CPUs, then 72 CPUs, then a machine with 1 GPU. This is a NVIDIA V100 here, and then one with 4 GPUs. What we can see is that as we increase the compute capability, we get faster and faster. And I'll come back to this side, this 4 GPU, which is actually a bit slower. But the very interesting thing here is that not only was the solution using one GPU faster, which we would have expected because this is why this GPU, these graphical cards are actually developed, but also this is cheaper. So it's not only that it's faster, but we also get a cheaper cost because it can do it so much quicker. So basically you can get a better accuracy for your model in a cheaper way using these GPUs. As I'll come back to this for GPUs, it's a bit difficult to compare 1 versus 4 GPUs because of how the architecture is. Basically, you have a parameter server and the 4 GPUs are training at the same time and sending updates to the parameters to a shared parameter server. So here it does look like the time for training was actually a bit longer, but this is actually the time to reach one epoch, which is one pass over the data. And while when using a parameter server, actually, you might reach a better accuracy in one epoch than what you would reach with one GPU. So the comparison is not exactly fair here. It would be more expensive for sure, but you might reach a better level of accuracy a bit faster. On the right is another result that we got, which is we ran a comparison with documents that we had the text version of. So we had the pictures and we send them to OCR, and then we compare how well is the OCR doing. And here you want to do 0. 0 means you're doing 0% error for your detection of text inside the document. And what we can see here is that on the left, the red is actually the open source software that most people are using, which is Tesseract. And you can see that it's making about 10% error, so meaning every 10 characters, there's one that's gotten wrong by the OCR system. And when we go to AWS Textract software, we get to about 4.5% and even 3.5% for Azure. Now, another thing that's interesting here is that even if you're not interested in cloud, for example, Azure provides now a container that you can rent from them and install on-prem to use their OCR. So this is not just a take-home for cloud. I think that finishes my presentation, and I'll send now to Ilana.
Oh, hello. Thank you, Francois. So today I'll run you through a use case of natural language processing at the ATO, which is for international risk identification. Next slide. Thanks. Thank you. Okay, so our goal was to search for indicators of specific risks for our client in international tax risk, to look for those risks in CBC reporting documents. So CBC is country by country reporting, and it implements Action 13 of the OECD Base Erosion and Profit Shifting Project, and requires companies to report on their revenues, profits and taxes paid by the global group, the operations and activities of the global group, and international related party dealings. So obviously it's quite a chunk of documents, and there might be various so we can identify searching through these documents. So, and then I've put up an example sentence where we might want to sort of identify that a company restructured in 2020 and what the nature of that restructure was. So we'll start on the left-hand side. So what we could do is a simple search, which relies on using Elasticsearch, which Francois spoke about, and that would index our CBC text documents, and that would retrieve documents according to a relevance score using the TF-IDF algorithm. And this is a frequency algorithm. So it's a measure of the frequency of a term in the document relevant to the frequency among all the documents in the corpus. So obviously you want if the document's relevant, the term will be overrepresented in that actual document relative to the rest. The problem with this is it's not a machine learning based approach. We don't have any labeled examples. So we can't sort of customize any kind of model for our particular risk identification scenario, and we can't evaluate the performance. Another limitation is that TF-IDF is based on strings and terms, not on any kind of context. So if you search for the word bank, you might retrieve a sentence or documents containing sentences such as the river bank, and documents containing sentences such as I extracted money from the bank. Whereas clearly the second sentence is more relevant in a financial context. So moving on to the middle here, what our current state is, we've developed a traditional machine learning pipeline for classification and adding our text, creating some features from the document using TF-IDF, and training a logistic regression model, and we've had some success with that. One thing to note is that we had the problem of lack of training data, and this is obviously a common problem I think that we'll all face. So what we used is an approach called weak supervision, which uplifts our training data using a set of rules. And we used a framework called Snorkel, which is an open source framework, to help us do that programmatically. And once we'd done that, as I said, we used a logistic regression machine learning model, trained on these weak labels and evaluated against ground truth or gold labels, enabled improvement. The main issue here is it's still not context aware. So if you have a more complex query, you might not recover some text where a specific term is not used, but a semantically similar term is used instead, and you want to make sure you recover all relevant documents. So that's perhaps an issue with our current state. Moving to this right-hand side now, talking about our status of these large language models, such as BERT, and these models have the advantage that they embed text as vectors, which actually entail the semantic meaning in those vectors, and that's based on the surrounding tokens for each particular token. And so these vectors are context aware. So when you search among these sorts of vectors for a particular term, you won't just pull out string matches, you'll sort of pull out semantically similar text as well. And these large language model approaches can rely on transfer learning, where we can use a model that has been pre-trained on a large corpus of text. And yes, to that question around SBERT, so I've got the little logo there. So SentenceBERT, we are currently developing a proof of concept around this future state, and that will involve using SBERT, which is implemented through sentence transformers package, which builds on PyTorch and Hugging Face transformers open source libraries. So that's what's coming up. So I'll move now to the next slide. Thanks. And this is our current pipeline. So our weak supervision pipeline with logistic regression. So we start on the left-hand side, and we've built an interactive labeling app, the Dash framework. We get our domain experts to do some labeling. Then we move into writing our heuristic labeling functions, which the Snorkel framework provides a set of tools for us to do that, and that allows us to label a large amount of the previously unlabeled text using rules such as, if this document contains a particular keyword, label it as positive, as in it contains the international tax risk, otherwise label it as negative. Snorkel actually has a program to deal with inconsistencies or correlation between labels. So if you use two or more labeling functions for the one example and they disagree, Snorkel has a probabilistic way of, I guess, dealing with that and coming out with an overall label or an overall a stochastic label. And then that can go into our final logistic regression model. And as you can see, we've got some good accuracy and precision and that through about 9 labels, we're able to get to around 5,000 weak labels, which we've been able to use for training. We'll move on to the final slide. And yeah, this is just an overall summary of the benefits and the impact for risk identification in the text. So machine learning with this weakly labeled data allows us to refine the basic search approach, the elastic search approach, so that we can train the model to focus on the features that are most important to business, because it's a machine doing a search. The next point is that if we can evaluate with X, identify model gaps and more semantic or contextual search and classification, and this helps to incorporate based more on meaning and intent rather than just string matching alone. And finally, I'd just like to credit Gitanjali Pradananga and Mayan Lai in my team, and we've worked together to research and develop this work. Thank you. I'll pass on to Hong.
Good morning, everyone. Good morning, everyone. My name is Hong. I'm Acting Director of Data Science at ATO. Today, I will talk about a recent project on automating review of documents. Next, please. Firstly, the ATO FIRB program. So what is FIRB? FIRB is Foreign Investment Review Board. That's part of Treasury portfolio. Foreign investments are very important to Australia's economy, providing extra capital for growth and creating jobs, improving consumer choice, and promoting competition. In 2017-18 year, $160 billion foreign investment flow into Australia. To support this, Treasury and ATO work together after they assessed more than 11,000 applications. The intent of the review framework is to maximize investment flow while also protecting Australia's national interest. ATO's role is to assess the impact of those proposals on Australia tax revenues. Here, ATO team is a small team, have to deal with a large number of documents, including those application, cover letters, various kinds of reports, communication with treasuries. Lots of work on manual, from reviewing a document, extracting of information from documents, manual entry into template afterwards. Today, I will talk about an analytics solution we built to automate the creation of compliance reports, support strategic risk planning, and the treasury compliance. Next, please. The technique I'm talking about here is called question answering. So it's like a reading comprehension, basically based on a text, then ask a question, and then it will extracting the answer. Here I will give a small example. So we have a paragraph talking about Super Bowl 50, an American football game. Then we can ask a question based on the article. Which team won Super Bowl 50? Then the answer is as highlighted in blue, so that's a champion Devon Broncos. So the idea is to use the paragraph plus the question and then derive the answer. Next, please. The technique behind this model is based on BERT. Firstly, we just do a quick recap. BERT is the bidirectional encoder representation from transformers. It works both directions, from left to right and from right to left for language modeling. It produces contextualized word embeddings, captures the word's meaning, but also relationship between words, the surrounding words. To train a question answer model, the input is tokenized paragraph and the question. Feed that into the BERT model. The answer is a span in the paragraph. To pinpoint where it is, so we introduce a start and end vector. Start vector contains the probability of each word in the paragraph being the start word. This is the start position of the answer in the paragraph. Similarly, we identify the end position. So by using this start and end vector, we pinpoint where the answer is as exists in the paragraphs. Transfer learning is about applying the pre-trained models into the problem at hand. Our documents are the tax council documents our tax officers dealing every day. And our objective is retrieving information from those documents automatically. So the way we do is we're starting from the Word document. We use various Python tools and packages to extracting the content from those documents. We then break into this into sections, paragraphs, tables, all the logical parts in that document. Then based on the sections, then we asking the right questions relating to that section. For example, what is the risk rating of the proposal? Then we use the answer. We use a question and the paragraph as input to the model, and then derive the answer. Next, please. So the project derives the benefit as in saving the FTE. So because and that enable our staff to focus on more high-risk applications. It's creating the automatic compliance reporting that give us also the confidence in the reporting by reducing errors and inconsistencies in the manual process. That reporting again following allow us to identify trends in the tax risk. We have already in the project we have been proven to using the open source model for fast application development. This model, the question answer model, in the future will be integrated into the generic data pipeline that we talked about earlier. The key takeaway message today I want to say is the question answer is a very promising technique, and we think that has wider applications, not just in ATO, in the current project I'm talking about, but also I think this is going to be promising in your organization as well. Thank you.
Perfect. So yes, thank you, Isabel. Let's move to ABS. Claire.
Thanks, Ying. Good morning, everybody, or almost good afternoon to those of you in the Eastern States. So I'm going to be talking about some ABS use cases for natural language processing. Could we get the next slide, please? I'm going to talk very briefly about two approaches that we're taking in the natural language processing space, and a bit about our intelligent coder, and about some of the lessons that we've learned in this work. So next slide, please. Okay, so as some of our presenters today have already mentioned, there's quite a lot of potentially useful unstructured text data available out there in the wide world. When we talk about unstructured text data, by the way, we mean data or sort of documents or other kind of text containing things that have information in them, but the information isn't sort of nicely and neatly available. So there might be information in there about a person's name, their date of birth, about a business, you know, about a price, but there's not, you know, a nice shiny arrow pointing to it that says this is the price. It's in there somewhere. It might not be in the same place in the document every time you look at it. And yes, you want to try and extract that. In particular, if we could extract some of this information and combine it with structured information, that's, you know, your regular type of unit record information that the ABS already has. We have quite a lot of that. It would be really nice. And this is not just a matter of gaining additional information. Sometimes it's about making approaches more efficient. So, for example, you can we already, I think, web scrape prices to input into the CPI. But if you web scrape in a very naive way, then kind of basically every time an online shopfront changes the layout of its web page, you might have to reprogram your web scraper to try and actually find where that price is. And there are natural language processing approaches that yeah, take a more might mean that you don't need to do that. So, and another application that we're looking at is online job ads. So next slide, please. So we have actually begun a project on named entity recognition. As I said, this is initially sort of focused on online job ads. So this is an approach where you look at a document and you say, I know there's certain types of things in here. There might be a name. So in the case of an online job ad, there might be something about us. There might be a salary in there. There might be a job title. There might be a set of required skills. There might be a business name. But all of these things might be in a different order in different job ads, or sort of laid out differently on different web pages. And we would like to be able to go to any job ad and extract those pieces of information and then link them into other data. And we're actually linking, we're looking to link this into a broader analytics project on the labour market that's going to be using graph-based data linking. But that's another talk for another day. Next slide, please. Okay, so you can just use sort of free text or unstructured data directly without having to try and extract the information. People usually talk about this as document classification or sentiment analysis, where you look at a document or a piece of text and you want to say, you know, is the person expressing, you know, positive feelings towards something or negative? Are they angry? Are they happy? We actually collect quite a bit of free text data. We, you know, try not to, but we get it anyway. It's probably increasingly useful to know about. So we collect comments from our interviewers in the field. They might write on a survey form whether, you know, the person in this household actually needs a translator before they can respond, or whether there's a big scary dog and the next interviewer should be careful. We have online surveys that we get respondent comments on, so they might say this question is difficult to answer, or, you know, things like that. We get calls to our helplines, people who want, you know, paper forms for the census, or also to, you know, ask how to answer questions. And occasionally we allow people to write free text into surveys in response to questions. And this might be in the form of complete sentences or sentence fragments. We've kind of done a few skirmishes in this area so far. We are looking at using this to classify interviewer comments and respondent comments. We have used it, I guess you could say, kind of formally in anger in an internal staff wellbeing survey with quite good results so far, I guess. So yeah. Next slide, please. And then we have something that sort of falls in between these two kinds of use cases, which is our intelligent coder. So the intelligent coder is a classifier, so you could sort of think of it as a text classifier, but it's also a way of taking free text and converting it into a structured response. In particularly, it takes free text fields and codes them to APS standard classifications. We have quite a lot of these to enable sort of efficient reporting against various different kinds of areas. So the intelligent coder takes a bag of words approach. That's a pretty simple way of encoding words now, but it's usually adequate for what we're trying to do in this space. So it doesn't sort of really care about context or word order. It just sort of looks at which words are present. But if you sort of think about, say, occupation, it doesn't really matter too much if someone writes, I'm a high school teacher, or if they write, I teach at Adelaide High School. You know, the words teach, high, and school are the ones that you want to extract there to work out what their occupation are. So, and then it has a support vector machine classifier that sits, comes behind that and classifies to the many very large hierarchical codes that we have. It's proven to be both more accurate and more efficient than our index-based autocoders, which we used to use for automatic coding. They were basically just dictionaries. You know, see a word, look it up, decide on the code based on that. And they were not very, they had to pass a very large proportion of codes over to human coders to be coded manually because they couldn't handle some of the more complex codes. So the intelligent coder does much less of that, handing over codes to human coders. But if you sort of, you know, dial back the amount that you try to get it to code, it codes more accurately. And it can learn to code pretty much any classification. So far, we've applied it in kind of sort of production to industry. That's like the ABS ANSIC code, to time use activities and to product codes and prices. We're working on applications to occupation, to health conditions, expenditure codes for household expenditure, and nutrition codes for a nutrition survey. So next slide, please. Lessons learned. These methods potentially provide a lot of value. So the intelligent coder is proving to be very useful. It's not just more efficient in terms of applying, like I said, like meaning that less codes get sent off for manual coding. It's also more efficient in that we don't have an index-based coder that's specifically for every separate code that we need to use. We have one system, one coder, and it does everything. So that's awesome. What we have found is that if you find yourself in the position where you're trying to do something that you haven't actually done before, in the sense that this isn't a case where you're trying to make something that you do manually more efficient, and then you may not be in the case where you actually have a lot of labels or annotated data to work with, and trying to get those is very hard work and quite tedious and unpleasant. So yeah, I think some of the ways that the other agencies have been working around that are very interesting to hear about. There's also, like, I think we've gotten to the point with the intelligent coder where we're starting to think about, okay, so what happens next? What happens if we now go and change a classification or a code? How do we retrain the coder to deal with that? How do we keep up with changes in the real world? So, for example, if suddenly a lot of people who might have called themselves business analysts or statisticians are starting to call themselves data scientists, you know, is the coder going to be able to handle that? And I think that a lot of NLP applications are probably in the same space, in that we've been doing a lot of thinking about how we get them to work in the first place. What happens in sort of 5 years' time, I guess, is the question. So I'm going to stop there. The next slide is just a question slide, but we're saving questions to the end. And I'll hand over to Kyla. Thanks, everyone.
Okay, good afternoon, and thank you very much for the opportunity to talk to you all about NLP and the challenges and the approaches that we take at ASD. Before I start discussing some of our more, slide please. Before I start discussing some of our more specific challenges and the solutions we've been experimenting with, I thought I might just give you a quick overview of what the Australian Signals Directorate is and what we do so that I can give some context to our problems and the challenges we face. Slide. ASD began as an organisation within the Department of Defence after the Second World War. On the 1st of July 2018, ASD became a statutory agency within the Defence portfolio, and at that point our purpose was updated. So ASD's purpose is to defend Australia against global threat and advance our national interests through the provision of foreign signals intelligence, cybersecurity, and offensive cyber operations as directed by the government. Next slide, please. The legislation that covers our functions is the Intelligence Services Act 2001, and in particular Section 7. So I've just listed on the slide all of the functions that are outlined for our organisation within that Section 7. So we're subject to regular audits by the Inspector General of Intelligence and Security to ensure that our activities stay within these bounds. And NLP is no different. It really adds an interesting dimension to the way in which we can apply and use the results of natural language processing, particularly when we're supporting the military or communicating foreign signals intelligence. Next slide, please. ASD has had a love-hate relationship with natural processing over the past few decades. On the one hand, it's always promised to be useful, but I think that what we've found is that as a whole, people not intimately involved in the development of the capability have not realized the effort it takes to successfully maintain NLP capabilities over time. Next slide, please. Our language technology and research team sits within our data analytics section at ASD. On Monday, this structure changes slightly when the developers of our NLP tool suite join our section. This is actually a really exciting change for us because it means that we can be extremely involved in helping to design all of the interfaces within which our NLP tools will be used, and to ensure that we can actually start capturing as much information as possible while analysts are doing their jobs to push back into our models and into our monitoring systems. Next slide, please. As I mentioned a few slides ago, ASD's function is primarily focused on foreign signals intelligence, whether it be for our intelligence, cyber, or offensive capability missions. Next slide, please. That means that by and large, we're not looking at English, we're looking at multilingual data. Not only that, we're looking at multimodal data. On any given day, we're processing a large range of structured and unstructured data, ranging from formal through to informal text and speech. But our problems don't stop there. The Australian government priorities change, and although we have a reasonable idea of which languages are of importance now, shifts in the geopolitical climate mean that ostensibly we could need to respond to requirements in any one of the world's approximately 7,000 languages. So that may be a little bit of hyperbole, and there are possibly a few that we could discount, but there are also a lot of very, very low resource languages that can pop up from time to time. This leaves us in a really interesting position because when you actually drill down into what state of the art means in the NLP research community, it's generally only developed for a handful of well-documented languages or low resource languages where the number of speakers is around the 50,000 to 100,000 mark. So what do I actually mean by the term handful? So as you can see on the slide, even Google Translate only works for 108 languages, which is approximately 1.5% of languages globally. And I'd argue that this number is actually lower when you look at what it provides as a reasonable translation for some languages. If anyone has had cause to translate Finnish, you'll see what I mean. Next slide, please. So what does multilingualism actually mean for us in practice? When we look at just the basic level of pre-processing that needs to be undertaken, that we need to maintain a capability for, and these are the capabilities that we need to maintain in order to index, store, and retrieve our data. We need to be able to identify, tokenize, and/or lemmatize our data. I'll come back to identification in a minute. Next slide, please. So there are many tools out there with pre-trained models for tokenization and lemmatization for some of the languages that we're interested in. And we've used and tested a range of them for different languages like Stanford Core NLP and Spacey. But we've also had to look at training some of our own models. And for others, we just have insufficient data, which means we're going through the process of instrumenting our tools to enable a collection of the marked up data that we require. After the data is indexed, we have a couple of processes we can run over our data, including named entity recognition and topic modeling. We're intending to build this number up, and we've been experimenting with fine-tuning pre-trained models for NER, particularly BERT. We've opted to use mallet and in particular latent Dirichlet allocation for topic modeling, but we'll be working on assessing other options in the future. Over the next few months, we expect to be able to move some of the work that we've been doing into production. We're also in the process of testing several different neural machine translation systems, some transformers and some statistical systems to allow for the range of languages that we're currently looking at. In addition to this, we've been building a computer-assisted translation environment which incorporates the machine translation and all of the dictionaries, translation memories, and everything that our analysts need to be able to translate and quality control the data. We've found that in some of the testing that we've done over the past year, that this can save 2/3 of the time that our language analysts take to translate a document, and a similar length of time for staff providing quality assurance functions. So in all of the tools above, we've assumed that only one language at a time is used in our data. So this is probably not a great assumption when we're looking at structured formal communication, but looking at more informal communications, we have to ask ourselves whether or not the assumption holds. Next slide. Seeing as I've raised it, you've probably guessed that the answer is no. So even McDonald's recognized this fact, and in the mid-80s used this ad to advertise the croissant. So how does Google do with code switching? So if you take a look at some of the paragraphs on that slide, you can kind of see that there's German intermittently sprinkled in between the English. Next slide. So like most language detection algorithms, it assumes that only one language is used at a time and that the first language used is a language for the whole document. So follow-on processing fails, and we can see that machine translation actually doesn't happen. It totally fails. So if language ID fails for us, we have difficulty indexing, retrieving, and automating follow-on processing. Next slide, please. If both language ID and pre-processing fail, information extraction fails, and of course machine translation fails spectacularly. And our analysts are back at the point where they can't triage easily, and so they're having to look through quite a lot of data. Next slide, please. One of our other main issues has been alluded to by, I think, all of our speakers, in that our infrastructure wasn't ready to be undertaking large amounts of NLP on large amounts of data. So due to security controls, we're not able to access commercial cloud technologies at the moment. And so we've got a small analytic infrastructure management team who are incrementally developing a variety of ML ops tools. So these include lightweight APIs, so ML flow, CI/CD pipelines, and continuous training pipelines. So given our legislative environment, we also have to look at putting considerable effort into the tooling around creating and deploying models and the authorities around those, storing our training data and our test results. We're also working on how we provide this information to our analysts in a format similar to Google model cards. In the near future, we need to look at how best to upskill our analysts to understand the problems associated with chaining some of these NLP techniques. Next slide, please. So we have absolutely no shortage of really interesting and extremely challenging problems that we couldn't begin to surmount without close relationships with defence science and technology researchers, researchers from ANU and other government departments. Just in closing, I'd like to really thank ABS and ATO for organising this workshop today. This type of event is a really important way to link NLP and data science practitioners across the APS.
Thank you very much, Kyla. All right, we are doing a great job on keeping to the time. So may I invite all our presenters back to the stage, please? And we do have quite a number of interesting questions. So I think the Q&A session possibly will run a little over time. To our audience, if you have to leave at 12:30, please feel free to do so. But you are also more than welcome to hang around for the questions and answers if you are available. All right, so let's start. The first question is that NLP advances fast. For example, BERT feels like history and GPT-3 is already yesterday. How can we keep up with the state of the art, not just in theory, but also in production, when it always seems 3 steps ahead of us? So how about Alistair from ASIC, what's your thought on that?
Yep, sure, thank you. I guess from ASIC's perspective, I guess there's not really much of a desire or a need to keep up with the state of the art. I mean, if you look at what the analysts want, what the business teams need, we can actually meet a lot of those needs with off-the-shelf algorithms and things that we don't really need to keep up with the state of the art at this point. We're happy to sort of wait and sort of allow the science, allow the science to match the engineering. So I guess the focus at ASIC is to sort of put things into production, and for those reasons we're picking up low-hanging fruit, and I think a lot of the off-the-shelf algorithms. So we're using PyTorch, NLTK, things that have been around for 5 years. So that's what we're doing at ASIC.
That's a very interesting point, because we do have lazy learning versus eager learning in machine learning. Sometimes lazy learning turns out to be most efficient. So thanks, Alistair. So how about Francois and Hong from the ATO? What are your thoughts? How about we go start with Francois first?
Yeah, I think I'm really with Alistair on this one. I think there's a lot of applications for which very simple techniques. The biggest gain that we have is actually going from no model to a model, and then taking off the shelf techniques like BERT or ExcelNet. I think that they're already very, very good techniques. I think for issues like Kyla was talking about, I think it's a tiny bit different, because once you want to do LDA or hierarchical Dirichlet processes or all of this kind of techniques, then you need to work a bit harder. Because they're low, because of the issues of low resource languages. But I think for people who manage English, I think a lot of off-the-shelf kind of techniques are really good enough at the moment.
Thanks, Francois. Hong?
Thanks, Ying. Yeah, I just have some thought about the international conference like KDD. So it's good to devote a little bit time to keep up on those latest development in the academic world. And there's also a lot of open source like Hugging Face, GitHub, to keep eye on their latest development there. People put their prototype implementations there. And I think that it is a balance. We need to be at the leading pack, but we don't need to be at the very front in that sense, because there's a lot of research effort involved. And I guess we are not academic researchers. We are more practical practitioners. So we have a very practical objective here to working with business with their automation and improving efficiency. as other people agree, yeah, the latest algorithm is not always the best solution. Yeah, we have to when we deploy something, there's also a lot of other factors likely to consider.
And very often, old is wise, right? Okay, thank you. Kyla, what's your insight here?
So I think that I agree with all three respondents so far. I think that one of the things that I've found in moving across into looking at NLP research is that most of the gains that are made paper to paper are really small increments. And it's not until there's something that's a really big game changer that it's worthwhile actually taking a look to see whether it's going to save us any time or save us any effort. Because there's all of the kind of integration load on changing our approaches. I think it's also really important to actually understand our problems fully and understand our analyst problems fully. Because without doing that, we're just going to get caught up in thinking this is so cool and we need to implement it now. And we're not actually going to be able to provide the level of service that our analysts are expecting.
Great, thanks, Kyla. So the second question is interesting. How do you choose between off-the-shelf product and development in-house? So how about we start with Peng from ASIC?
Hi everyone. I think Alistair sort of alluded to some of this response. I mean, we have explored off-the-shelf software products, and I think what we're doing at the moment is really trying to actually, sort of get our infrastructure up and going so that we can actually even do the basic work of NLP, which is, feature extraction, for example, and then maybe looking at keywords in context with other words. So in terms of off the shelf, I've personally found it quite expensive. And I think also looking at our infrastructure and making sure that if we do bring in an off-the-shelf product, that it fits in with our ecosystem, so to speak, in our data lake and so forth. And then we've got to think about, the solution that the business wants, which in our case is usually bespoke in the sense that, they want an interface that's flexible and also the ability to do things like, get straight access to the document and paragraphs and so forth. So in sort of trying to do that, I think you've got to weigh out whether, off-the-shelf products has all those bells and whistles, whether we really need it or not, and whether your problem is more specific. And then you could probably just use, open source software and things like that. So that's been our experience at ASIC.
Thanks, Peng. Debbie from the ATO.
Thanks, Ian. I think a lot of presenters already answered some of this in the previous question. So I do agree with what they said. For the off-shelf products, if you find the right products, you get instant outcomes. So which is the good thing. But it does have a lot of constraints. And it takes a long time for all those state-of-art algorithms to get into all these products. So, but if we do actually have a larger team, have a lot of more resources, I think the customized in-house development will be the way to go, because it allows us to have a lot more flexibility, able to do a lot of customization for specific applications. But it does need a lot of more resources, and you need the people with the right skills.
And also, even with the in-house development, we don't do it from scratch, right?
No.
We build upon the pre-trained models, which is open source. Actually, Gartner has named open source to be one critical trend to the future of data science and machine learning, because Open source accelerates the creation and dissemination of ideas, and also because it's powered by community, and community out-innovates any single company, even the most advanced one. So thank you very much, Debbie. Okay, Claire from the APS.
I think it comes down ultimately to what your requirements are and whether the products that are available can meet those, and in particular can meet the ones that you're maybe not willing to compromise on. So certainly when we developed the intelligent coder, we sort of looked around at the marketplace, and one of the things that's difficult to do with sort of commercially available products is handle hierarchical codes. And many of our codes have that kind of hierarchical nature. So that was the big kind of killer for us, I guess, in a sense that led to us building it in-house. There's, you know, I think, yeah, you've just got to think about your requirements and the costs, and don't forget that there's often kind of hidden costs in there. Like, you know, it can be difficult sometimes to take a commercial product and integrate it into a pre-existing kind of process or pipeline that you might have. And then there's a sort of a question of ongoing support as well. So, you know, that could cause you to lean either way. It might be nice that a commercial product comes with like a built-in support that will last for as long as the product will. Whereas, you know, if you do something in-house, you're always going to have someone hanging around who knows how this thing works and how to fix it if it breaks and things like that. So yeah, I think ultimately it comes down to what are your requirements.
Wonderful. Thanks, Claire. Kyla.
So for us, there's also the added problem of deciding whether we're willing to accept the risks surrounding a model built by somebody else. So when we need to really strictly adhere to the legislation that we work within, we need to be sure that either we understand all of the data in the model, or we understand how the algorithm's working so that we can actually give some level of assurance to our follow-on customers that things derived from machine learning and AI are actually like kind of sound. So I kind of see a spectrum of like when COTS products are acceptable and when they're not. And so for us, COTS products or GOTS products are kind of acceptable in those areas where you're doing things like pre-processing, you're doing things like some of the like kind of named entity recognition, or you're doing things like that. But then when we get to the point that if we're relying on a translation, we really need to like kind of know that the translation or what a decision is made with follow-on analytics is actually it's a well-reasoned like kind of response. I think the other thing that we found recently as well is that a lot of the off-the-shelf products are just rebadged open source that's being sold for much more than it's worth. And so we're looking a lot more at open source products than we are at COTS or GOTS.
I can't agree with you more, Kyla, on your last point. I think it's okay if companies want to earn money out of open source, but I just hope they can feed back to open source to make it even bigger and better, right? Okay, thank you. So the next question is, what is the most challenging task in NLP according to your experience? Ilana from the ATO.
Thanks, Ying. I suppose sort of referring back to my talk, it probably relates to the data, I guess, that you'll be using, and that's probably not totally dissimilar from regular machine learning, in that you have to be able to sort of, well, the first issue is dealing with unlabeled data, because a lot of the documents that are submitted to ATO and other regulatory agencies will not come with labels such as high risk or low risk, and getting our business users to invest their time in labeling documents so that we can build cool machine learning models. That's often they don't want to invest that time, or you need to sort of explain the benefits. So that's where using a snorkel and the weak supervision approach helped us to sort of allow business to invest a minimal time in the labeling, and that we could get a lot more training data from that. In terms of just dealing with the data generally, I think NLP has special challenges because it's an observation of the truth, which you might get, say, with structured data, but it's also mediated through a human being, because it's sort of what someone thinks is going on when they write text. It's a human that's written it. So when you're curating your data or collecting your data that you're going to be used to train a model, you've got to think about, coverage. You've got to think about, cleaning is balanced and unbalanced data sets. So if you just sort of scrape stuff from Twitter, and try and build a model from that, it might not be very accurate. So I think there's a few extra questions that go into data collection and curation that apply to NLP that are even more challenging than when you're collecting traditional structured data.
Fantastic. Thanks, Ilana. Okay, next. What's important about implementing an NLP solution from your experience? How about Pong from ASIC?
Yeah, I think my thoughts on that are to really, I think, involve data operations and data architecture team early in your project. Particularly, I think data architecture, if your current pipeline needs to be tweaked to accommodate the design, the solution design, which is what we found lately, and data operation really to support the implementation and the ongoing support of the application itself. And I think from a data science perspective, to make sure that the requirements are clear from the business to the support team, which is the data operations and architecture team, so that they can actually understand the solution and also how to support it.
Thanks, Pong. Claire, any insight from you?
I think my answer would be quite similar to Alana's in some respects. I think it's very important to make sure that you're asking the right question and that you're setting up your problem and your algorithm to make sure that it's actually providing an answer to that question. And I guess, yeah, again, to make sure that you're getting the right training data, again, the right data to answer that question. I'm sure we've all seen some of the really horror stories going around about machine learning algorithms gone horribly wrong lately. So yeah, we don't want to fall into those kinds of traps.
They are fake AI, Claire. Thanks. Thank you. Okay, now next question is particularly for Alastair of ASIC. So you did mention an automation process. Actually, this question is relevant to what Claire just said. Is there a worry that this automation process will gloss over details and analysts might pick up manually? How are you trying to mitigate this? But another comment from the same audience, comparison across the data lake is a good idea. Yeah. So, Alastair, can you take the floor?
That's a very good question. We question come up a lot when we were talking about. Oh, yep. Can you hear me? Yep. So yeah, no,
I can't hear you.
That's a very good
Alastair,
question.
can you test your? Alastair, can you test your audio? I can't hear you. Yeah, we can. Keep talking. Yeah.
Okay. Okay. Yeah, that's a very good question. That came up quite a lot when we were talking to the business teams. What we've done actually is that we've actually finished the core algorithm that was completed last October, and we've actually been running that simultaneously with the existing business process. So while we produce output from the last couple of months, the corporations team is still doing the manual review, and that's probably going to continue for until October this year. So we'll have a year where the analysts have been doing their own review, and we've also have output from our algorithm. And the idea is that we'll compare the two, and see what our application is missing, see if the analysts have missed anything, see what the difference is, and combine that into future updates. I sort of alluded to that issue in my learning slide. I was talking about one of the challenges that we're facing is how to actually incorporate those changes. So this is one of the ways we've sort of tried to overcome that issue of analysts not really trusting it, and also just improving the reliability of the algorithm itself. Yeah, hope that helps.
Thanks, Alistair. One question to Debbie. How well does the image classifier, or Francois, how well does the image classifier work with faded text on a receipt?
Yeah, that's an interesting question. I think the image classifiers. Okay, the first thing to say is that in the proof of concept, this was kind of a general pattern of like a design pattern for handling a document pipeline, and it depends a bit on the final task that you want. But if the aim of the image classifier is to detect if it's a document or not, usually this is fairly simple. But we did observe, it's kind of interesting because we did observe a lot of faded text in these. So this data set we're using is a public data set of receipts that have been, that people have actually annotated manually. And a lot of these receipts had text in the back of the receipt as well. And so when they get scanned, you also see this kind of text that's coming through the receipt, and the OCR gets quite hard by this. And there is actually a lot of the incorrectly recognized characters are just characters that are added by the OCR because the text is coming from the background or from a logo or from, like you might have like maybe a draft kind of filigrane at the back of the receipt. So I think for the image classifier it's fine, but in the process for sure this has an impact.
Thanks, Francois. Also, since I have you here, Francois, you did have a slide in your presentation where you compare the performance across different configurations. And the question is about why 4 GPUs actually incurred longer training time than 1 GPU on the same data.
Yeah, so I think it's a good question. It comes to the what I touched on a little bit as well before, which is how do you train with 4 GPUs? So usually the way it works is that if you don't want to have kind of blocking communications between the processes, you have your 4 GPUs that are running the model through the data, and they asynchronously send updates to the parameters. And so that's what we call the parameter server type of model. There's different approaches, but that's the one that most people use. And so you have a bit of loss there because you might be updating parameters that you had read after they had been updated already. So you might kind of rewrite some of the data there. So that's one reason. The other one is how do you compare basically the execution time of this model, because 1 epoch on 4 GPUs is actually usually getting you to an accuracy that's much better than 1 epoch on 1 GPU. So if we wanted to do things really properly, we would have to say, what was the cost to reach a particular level of accuracy, which is something that we haven't done just to make the comparison easy.
Thanks, Francois. Hongjian, the next question is to you. Is the question answer project still in research and development stage, or it's already in production?
The short answer is not yet in production, but when we show the result to the business getting really excited. They want this in their they want you use basically now. But as as we all know, the actually deploying the analytical models into a business process have to be fit into the business process. It's not just the data scientists. It's also have to work with other teams like software engineers to make this fit into their business process, to make them really streamlined. So that is something ongoing. We're going to continue working with the business team, to develop and
Thanks, Hong. Yep. Kyla, this question is to you. Is it difficult to understand spoken English with strong accent, which is quite common in the Australian multicultural environment?
So I think you need to take a step back from that as well. So most of the automatic speech recognition models have been built using American or British English, usually American English. So actually understanding Australian English and just the broad Australian accent is really hard. And then when you kind of layer on top of that any additional accent, it does make it quite hard to do. We don't really look at that. It's just one of the things that we've spoken a bit in length about to defence science and technology, because we're not typically interested in the well, we're never interested in the Australian environment. But yes, it is difficult.
And there is another relevant question to you, Kyla. How does NLP work with slang in the languages used in communication?
If the slang has been incorporated into our models, it does brilliantly. If we're talking about models that we've picked up from elsewhere, it kind of ranges. If people have only been using the data that you get from like sort of the United Nations and all of the like typical data sets, it doesn't perform all that well.
No worries. Thanks, Kyla. So now comes a question for all our panelists. How do you ensure that off-the-shelf products or solutions comply with Australian data storage and data use laws? That's a very good question. So let's go around the table to ask everyone. How about I start with Kyla, because I have you right here.
Okay. Yeah, so that's one of our really big problems. And one of our other problems is that we don't have staff in our security and in our legal sections who have a good enough understanding of the technologies to be able to make the assessments that they normally would on products that we're buying into the organization. And so I think it's going to be something that there's much more of a focus on from the APS perspective over the next year or so. It seems that seniors are starting to ask questions about those sorts of things.
Thanks, Kyla. Then let's move to ASIC. Pong, any insight?
I can talk with one. If not there.
No worries. Understand you. Oh,
yeah.
we have Pong now. Yeah.
That's okay, Alice. So why don't you take this one?
Yeah, just from a first pass, I guess any cloud-based service has to be IRAP certified. So yeah, I think it's a sort of Australian government requirement for a lot of these cloud services. Just to bring it back to our own use case, so Amazon Textract isn't IRAP certified, which is why we're actually not able to use it for specific confidential for documents classified above, I think, protected. But we are able to use it for corporate prospectuses. But yeah, that is something we keep in mind. So the certification that is the key sort of gate, I guess, to determine whether we use the technology or not.
Yeah, and I think just to add on to that, with what Elsa just said, I think when we do have sensitive or personal information in documents, which I think we were approached by the markets team at ASIC to actually help them with a problem which will involve NLP, we couldn't actually undertake the project because of the tools that we have that weren't IRAP certified. So if there is one and anybody knows about it, please let us know.
Thanks, Pong. Then our ATO people, Debbie, any insight?
Actually, opposite to ASD, we do have EST security team here at the ATO. So in that case, for all our applications, all the software that we're going to use, we have to go through all the security check and make sure that everything are allowable to use for our data storage and is compliant with the security requirements. So we are actually quite bound with our EST security policy.
Indeed, indeed. Francois, anything to add?
Maybe I'll just rebound. There was another question about cloud as well and the security for cloud. So maybe I can comment on that briefly. I think, for example, a lot of people have been talking about Extract, which is the OCR for AWS. Things are evolving pretty quickly on that front. I think when we started this POA last year, Extract didn't have a private endpoint, which meant that the machine that was querying Extract, that was using Extract, had to have access to the internet, which is usually at the ATO, at least our modeling machines don't have access to the internet. So that was a limitation, but it's been a few months now that Extract has, for example, a private endpoint. So there's a lot of things like that for us in using cloud that usually all the servers are part of a VPC, so it's like a virtual network, and they only communicate back to the ATO's intranet. They don't have any connectivity to anything else on cloud, which might then limit what you can access and what you cannot in terms of software, even within cloud.
Thanks, Francois. Ilana?
Yeah, look, I don't think I have too much to add beyond sort of Debbie and Francois's comments related to this. So yeah, I think that there are topics around the infrastructure and movement to cloud sort of relate most to this question. So I'm happy with their answers.
Wonderful. Thanks, Ilana. Hong, anything quick?
Just quickly to mention, to sort of that kind of process, we sometimes want to test new tools, new piece of software, have the innovation machine, which can be very, like a sandbox, so with no connection to our classified data. So that's a place we can play with to testing new tools.
Well, Claire from the APS.
I suspect my answer is going to be pretty similar to some of the others, in the sense of basically the answer is through a very large amount of work by the TSD security team. That's our IT security team and others. So I guess in addition to all of the standard legislation like privacy laws and things that cover everybody else, we also have our own set of legislation that governs how we manage and especially treat the confidentiality of our data. And so we are just very, very careful about anything that comes inside of our IT environment, and it's very, very strictly vetted and tested, I guess, before anyone gets to use it on real data.
Wonderful. Thanks, Claire. On that, Kristen, I will ramp up our question and answer session and give the floor back to you. Thanks, everyone.
Thank you so much, and thank you to all our presenters. It's been a great workshop today. Thank you for excellent question and answers from all our participants. It's been very illuminating. Just in terms of next steps, reminder that this particular presentation will be loaded to the APSC website. So if you want to go back and view parts of that, we'll also try to make available the speaker contacts where speakers are happy to be contacted for further questions directly. So we'll do that shortly. And then, of course, you also have from earlier in the presentation the contact details for our Data Professional Technical Forum organisers, so that if you do want to get involved in any of our future workshops, if there's a topic you'd like to present on, we'd love to hear from you. So thanks again to the ATO for hosting the event today. Thanks again to all our marvellous speakers, and we look forward to seeing you hopefully around October for the next workshop. Thanks everyone.
Thanks everyone.
Thank you.
Okay, bye.